this video, I write an assembly language program that prompts for and reads a decimal number. The program should then display the number of ones in the inputted numbers binary form. A hint is to use the logical shift instructions. Test the program by entering 30,000. In binary form, there's 7 bits. There's 7 1 bits. So our answer should be 7 when we prompt the user and they enter 30,000. So to start, I'm just going to do exactly that. I'm going to prompt the user, load effective address into R0 with prompt. I'm about to describe what prompt is any minute. So I'm just going to say load prompt, and I'm just going to go ahead and halt and specify what prompt is. It is a string, enter a number. I'm going to do a little /n, just a line break. So this loads. Now I'm going to print that to the screen. So SOUT R0, and still using R0, I'm just going to DN whatever the user enters. So I'm just going to reuse R0 right there. Now right here, I'm moving 0 into 1. I'm just creating a count variable. This isn't really a count variable. It's really a 1 counter. I say a 1 counter. Counts how many ones in the binary number. Let's just put it like that. Alright, so now we move 0 into there. So now we have our count variable. We've received a number from the user. Now I'm going to just start this loop and do a shift right logical of R0, which that's where the number is that we want to mess with. So we're just going to say shift right. I know this says shift left, but shift right seemed to do it just fine for me. So I'm just riding with that. So shift right of R0, and it gets a little tricky coming up. It's gonna do a line break right here, and then print to the screen. Let's see. Oh yeah, we have to load. We have to first, before we print, we load another display. So we're just gonna print to the screen. So we're going to load into R2 display, and let's go ahead and just define. I'm gonna go ahead and back all these up actually. Okay, so these are all backed up. Now I'm going to just define what is display. Display is another string, and this one is going to tell the user how many number of 1 bits they have. I'll just do another line break. Alright, so we load that. When we go into our loop, we load that, and then we okay, right. So right here, where we have this loop, I need to add something. Right under it, the very first thing I do, so I shift it right, and now this is very important. This is a branch carry, BRC. The carry is carrying that last bit that just got shoved off of the number. So I just do a branch carry on, if after that shift, if what's in the carry flag is a 1, either way, I just call add. I'm gonna branch to add. I'm gonna create that way down here at the bottom and say add. Let's not add any emojis. Okay, so branch to add. What is add? Well, I'm just going to add R1 equals R1 plus 1. So we just increment count if carry if branch to carry is true. If the carry flag is true, then branch to add. Sorry. Alright. So now we got that in there. I'm just gonna say increment too. So I'm just gonna say increment right here. And also I'm gonna assign halt. I'm gonna assign end to halt. This just makes sure that we can skip over this add if we need to. If we need to skip over the add, then we'll just call end. And by the way, after we do the add operation, we're going to want to go back into the loop. So notice how we're out of the loop. So I'm going to call an automatic branch, an unconditional branch to return, and I'm going to specify return in the loop. So I'm going to say return to loop, and then up here, let's see, I'm probably going to do a compare. So return right here. So after I've done the check, now I'm going to compare, and I've already added to the bits. Now I'm going to compare R0 with 0, and basically this is just shifting along. So once it's shifted all of its bits, it's just inserting a 0. So once it's shifted enough bits, it's going to equal 0. So that's kind of my condition. My exit condition is I'm comparing this to 0, and while it's positive, while it's not 0, so there's still bits left in there, I'm going to keep going up the loop. So the real loop is just these 4 lines, and then I just kind of have a way to exit the loop and do an add statement, and then I have a way to exit the loop and just do a halt statement. So now we can, right here where it loads, I'm going to add an S out or 2, because that's how we, I don't know why I wrote increment right there. I'm going to load display right there. Okay. So now I'll S out R2, and this is where I tell them, this is on display. This is where I say your number of bits. So I'm going to decimal out D out R1. Now this should work. When a user enters 30,000, hopefully we get 7 after all this. Oh, sorry. Let me run that's the wrong one. Let me run 07. Enter a number, 30,000, and we're in a endless loop. So I need to add a break end right here, and what this will do is get us out of that loop. Right now we were just jumping over. It was an endless loop, and it was just going to add, and then it was branching to return, and then it would go through all this, and then it would go to add, and then it would branch to return. So it was just kind of going. So now we need to make sure that right here we need to break to the end, and that way it's fully controlled. So now let's try that. Let's just say end program. All right, now let's try this. See if it gives us 7 when we enter 30,000. Alright, so enter a number of bits, 7. And it had some crazy behavior up here. That's just from that endless loop. I just needed to use the end address that I put in place. So I put it in place right here, end halt, and then I never actually jumped over add. I never actually used it. And so adding that right there gets rid of that loop. So I have a condition right here to jump to the end no matter what when this happens. So this is actually outside of the loop too. But what we were doing is we were exiting the loop, and then we would go through this, and then after this add right here, before this was in there, we would go to this add, and then we'd branch back into the loop. So we would leave the loop and jump back in. Now we're making sure that we leave the loop, or that we don't jump back into the loop once we've exited. Alright, I hope this video was somewhat helpful, and hopefully you learned from my endless loop mistake.